Hi, thanks for joining. I have an update to the process here and I'm sticking it at the beginning of the video, the old video, in case you've already watched it before. There's one more step that you will need. If not, you will do what I'm showing you now at the end of the original video. So basically the issue is this: after using the printer for a while, I realized that the new value that we were setting was not being retained after a power cycle of the printer. Did some more research and it turns out that for whatever reason on the Ender 3, it does not actually update the configuration in the firmware with the command to save or commit the change. So it looks like it works, but you don't catch that it's broken until you power cycle. So there is a workaround. So if we're using Octoprint, you'll go into Octoprint after you get your new extrusion value, and you will click on the wrench or the spanner, depending on the side of the pond that you're on. You'll click on G-code scripts, and then you will actually stick the command to set the new extrusion value here in the before print job starts dialog box. Click save and click close. So in this example, M92 space E, and I have all caps there, is the command to set our extruder. The value that I came up with on my printer was 104. Your value may be different. It could be 103 or 100 or who knows what it would be. But that new value that you get is what you'll stick there. You'll click save, click close. And now what happens when you go and start a print, it doesn't matter what G code you've got here, Octoprint will issue that command to set the extrusion value before the G code starts. This is working really well for me. I've been slicing with Cura. Cura does not put that command anywhere in its G code, so it's not going to be it's not going to override what we're doing here in Octoprint, and it's working great. Okay, I'm getting really good prints now. Solid extrusion. Nothing's under extruded anymore. It's not over extruding. It's working really well for me. So you'll need to do this. In order to get this set, quote unquote, every time you go to print. The only thing you'll need to remember is that if you switch out rolls of filament, you may have to go through this process, right? Because not every roll is equal. Some have a little different diameter, or maybe some filament is just a different consistency, and so it's being pulled or pushed through that extruder at a different rate for whatever reason. And so if you're doing a test print and you see that it's under extruding or over extruding, you'll need to go through this process, find out the extrusion value for that roll of filament, and then come in here and set it. I don't see a way to create a profile in Octoprint for your filament that we could kind of tie that value to. So unfortunately, you'll have to keep track of it manually with your rolls. Maybe write it on the spool of what your extrusion value is, and then come in and set that in Octoprint before you start printing with it. But at any rate, this is working great for me. So I will start the rest of the video now. And thanks for watching. Bye-bye.
Okay, the first thing I need to do is change my filament because as you can see here, I have a black filament and I need to mark my filament to be able to measure it. So I'm going to heat up my hot end here and remove this filament. So first things first, let me heat this up to 200 degrees. And while that's heating up, I'm going to get a different color filament that'll be easier to mark on. Okay. And now I'm just going to go ahead and raise my the new filament in there real quick, and I'm just going to raise my Z stop up. And what I'm going to do is I'm going to go ahead and prime this filament through. just to make sure that I've got, good solid bead in. So I'm just going to extrude a good 10 millimeters here. Oh, a little dark in there. Yeah, that's good. Okay. So now what we need to do is we need to measure the amount of filament. The goal here is we want to mark off around, 100, 150 millimeters on our filament, and then extrude 100 millimeters, and we're going to measure the difference. So we're telling Octoprint that we want to extrude a certain amount, and it is sending that G code to the printer. The printer is then telling the motor, hey, move 100 millimeters, right, on this extruder motor. But what ends up happening with a lot of these motors is that the steps that they actually move is different. Okay, so it may tell it to move 100 millimeters, but in fact it only moves 50. Or it may move more than that. It may over extrude, and it may move 120 millimeters instead of just moving 100. It's pretty common. So what I'm going to do here is I'm going to measure this off, and I have a ruler that measures in millimeters, and I want to try to get as accurate as I can to get this straight. And I am measuring to the end of my inlet, where the inlet goes in, where the filament goes into this. Got it flush with that. So let's see. So 1 centimeter is 10 millimeters. So I'm going to go to 15. That would be 150, so I'm just going to mark this guy. And all I have on me is an ink pen, but that's going to work. And I'm also going to mark 100 millimeters just to mark it. All right. Sounds good. And if all you have is inches, you can mark inches in this. Use the calculator to convert. You want to try to get to, just a number, like a solid number, not a fraction for your millimeters, right? Because we can move it in, 1 millimeter lengths. So as you can see there's the camera with my mark. Let's see if we can move this and get a little bit of a better picture of the mark there. So there's my mark. There's actually 2 marks. There's one here and one here. So I'm going to go ahead now and send some commands via Octoprint to the printer. So let's see here. One of the first things that I want to look at is I want to get the current steps that are set in the Marlin firmware. So I'm going to go here to Terminal, and I'm actually going to type in a command. So I'm going to type in the command M503 into Octoprint and hit send. And let's see here, what did that give us? Let me suppress temperature messages for now. And that looks like that's doing okay, good. So I typed in M503. Oh wait, steps per unit. So 93 steps per unit, and my feed rate is 25 millimeters per second on my extruder. So I'm just going to write these measurements down. So my steps per unit are 93 on the extruder. .00. and my feed rate, my max feed rate is 25.00, and that's millimeters per second. Okay, so awesome. All right, so now what we're going to do is we are going to advance our extruder. So there's a couple of more commands we're going to type in. So we're going to first reset the extruder. So let me just type in this command. It's G920E0. Okay. It tells me it's okay. Now we need to type a command that's going to extrude our filament. So that's G1E100F90. And what this is going to do is extrude the filament 100 millimeters, or tell the motor to do that. And so the extruder is going to do its thing here. And mine is spitting out its filament. All right, awesome. So mine is short, so I can still see my mark. So that means that I can see the 150 mark, so that means I didn't extrude over, but I see my 100 mark as well. And it looks like I am right in between 10 and 11. I'm just going to say that looks more like maybe more like 11 millimeters. So I have an 11 millimeter differential here. So let's go write this down. So my distance that I went, right, was 100 minus 11, which equals 89. That's how far it traveled. Okay, so what we're going to do now is we are going to use a calculation. So we are going to take our old step value. So mine steps per unit was 93. I'm going to multiply that times 100 because that's what I tried to extrude. And then I'm going to divide that by the actual length that was extruded, which was 89 millimeters. So let me just pull up a calculator here. Okay, so let's just pull up a calculator. And let's see if we can do some quick math. So for me, my old steps, 93, that's what it's set to now. I'm going to multiply that times 100 millimeters, which is what I tried to extrude. Okay, and then I'm going to divide that by the actual amount that was extruded. And that gives me a new value here of 104.49. So now I'm going to go in. This is basically now my new steps, right? So I'm basically under extruding a little bit here. So I'm going to correct that. And what I'm going to do is I'm going to go back into Octoprint, and I'm going to type in some commands here. Let's go ahead and try to just try this again. So M92E 104. Okay, so that's it. All right, so now that I've typed this command in, the M92 with a space E104 now I'm going to go ahead and I'm going to save this value. So this is temporarily stored. So M500 now committed that. Awesome. So now what I want to do is I really kind of want to run the same test again. I want to see if I can extrude, 100 millimeters worth of filament here and get this guy to, measure pretty much like he's spot on. So let me go ahead and reheat the hot end. Since the printer reset the connection, I lost that command. And I'm going to go ahead and remeasure, remark my filament. Go back to my terminal, and I'm going to do G1 extrude 100 at 90 send. So GE 100 F90. And what I should see now is my filament should do its thing, and this mark basically should go right up to the edge of my extruder. So my old marks will disappear, and this guy should go all the way in. That's what we're hoping for. Should be flush, I should say. Like it should kind of just match right up with the hole there, and shouldn't be short, shouldn't go in past the hole. Awesome. So that's just about perfect. And so now our extruder has been recalibrated. So basically what we've done is we have gone into the firmware and we have told the printer, hey, now I need to change the steps because the steps that the extruder is actually moving is different than or isn't calibrated right. It's telling it to move 100 millimeters. The motor's moving what it thinks is 100 millimeters, but really it's not because the steps were off. So we need to recalibrate those. So I will post the equation in the notes of the video. And again, just to kind of recap, you're going to mark on your filament by measuring here at the flush with your extruder, like where the filament enters the extruder. You'll measure out 100 millimeters and you'll mark it, and then you'll measure out 150 millimeters and you'll mark that. And then what you will do, or you could do less. I mean, I'm doing 100. You could just do 50. You could do 25, whatever you can measure really. I'm doing 100 just to kind of get a good even number here, but you could use any value just as long as you're extruding the distance that you are measuring to. So if you're measuring to 25 millimeters, you're going to extrude to 25 millimeters. Just remember to measure more or less. I mean, really, it's probably better to measure out, like 20 millimeters, 25, 40, right? And so that way you can tell, you can measure. If I'm trying to do 25, but it only moves 20, right? Then I know I'm under extruded. If it moves out to 30, you're over extruded by so much, right? Okay, so they say the proof is in the pudding. So let's see if we can get close up here of this cube. And I have to say this came out pretty good. Before I had a lot of little holes on the top of my Z. And now I just have the one line that's there. That's supposed to be there, so that looks really good. And as I rotate this thing around, I mean, just it looks great to me. A little bit of ghosting that I need to figure out, but I think that might be partly from the infill pattern that I'm using. But overall, this thing, I mean, looks good. the first layers here. So we actually can see those, that first layer. I mean, that looks great. Just awesome. So hopefully this helps you out. It looks to me like I'm getting much better results now, much better layers being put down, and I think my extruder is actually dialed in now. So hopefully this helps, and I'm looking forward to seeing pictures of a really good cube once you're done. Thanks.